Logicism is one of the schools of thought in the philosophy of mathematics, putting forth the theory that mathematics is an extension of logic and therefore some or all mathematics is reducible to logic. Bertrand Russell and Alfred Whitehead championed this theory, created by mathematicians Richard Dedekind and Gottlob Frege. Dedekind's path to logicism had a turning point when he was able to reduce the theory of real numbers to the rational number system by means of set theory. This and related ideas convinced him that arithmetic, algebra and analysis were reducible to the natural numbers plus a logic of sets. Furthermore, by 1872 he had concluded that the naturals themselves were reducible to sets and mappings. It is likely that other logicists, most importantly Frege, were also guided by the new theories of the real numbers published in the year 1872. This started a period of expansion of logicism, with Dedekind and Frege as its main exponents, which however was brought to a deep crisis with the discovery of the classical paradoxes of set theory. Frege gave up on the project after Russell recognized and communicated his paradox, exposing an inconsistency in naive set theory. On the other hand, Russell wrote the Principles of Mathematics in 1903 using the paradox and developments of Giuseppe Peano's school of geometry. Since he treated the subject of primitive notions in geometry and set theory, this text is a watershed in the development of logicism. Evidence of the assertion of logicism was collected by Russell and Whitehead in the Principia Mathematica. Today, the bulk of modern mathematics is believed to be reducible to a logical foundation using the axioms of Zermelo-Fraenkel set theory, which has no known inconsistencies. Thus, to some extent, Dedekind's project was proved viable, but in the process the theory of sets and mappings came to be regarded as transcending pure logic. Kurt Gödel's incompleteness theorem undermines logicism because it shows that no particular axiomatization of mathematics can decide all statements. Some believe that the basic spirit of logicism remains valid because that theorem is proved with logic just like other theorems. However, that conclusion fails to acknowledge any distinction between theorems of mathematical logic and theorems of higher-order logic. The former can be proven using the fundamental theorem of arithmetic, while the latter must rely on human-provided models. Tarski's undefinability theorem shows that Gödel numbering can be used to prove syntactical constructs, but not semantic assertions. Therefore, any claim that logicism remains a valid concept must strictly rely on the dubious notion that a system of proof based on man-made models is precisely as powerful and authoritative as one based on the existence and properties of the natural numbers. Logicism was key in the development of analytic philosophy in the 20th century. Origin of the name logicism. Graton Guinness states that the French word logistique was introduced by Couturat and others at the 1904 International of Congressive Philosophy, and was used by Russell and others from then on, in versions appropriate for various languages. Apparently the first usage by Russell appeared in his 1919. Russell referred several times to Frege, introducing him as one who first succeeded in logicizing mathematics. Apart from the misrepresentation, the passage is notable for the word which he put in quotation marks, but their presence suggests nervousness, and he never used the word again, so that logicism did not emerge until the later 1920s, about same time as Carnap, but apparently independently. Fraenkel used the word. Without comment he used the name logicism to characterize the Whitehead-Russell position. Carnap used a slightly different word, logistic. Bayman complained about its use in Carnap's manuscript, so Carnap proposed the word logicism, but he finally stuck to his word choice, logistic. Ultimately, the spread was mainly due to Carnap. From 1930 onwards, intent, or goal, of logicism. Symbolic logic. The overt intent of logicism is to reduce all of philosophy to symbolic logic, or to reduce all of mathematics to symbolic logic. As contrasted with algebraic logic that employs arithmetic concepts, symbolic logic begins with a very reduced set of marks, a few logical axioms that embody the three laws of thought, and a couple of construction rules that dictate how the marks are to be assembled and manipulated, substitution and modus ponens. Logicism also adopts from Frege's groundwork the reduction of natural language statements from subject, predicate, into either propositional atoms, or the argument, function, of generalization, the notions, all, some, class, and relation, as perhaps its core tenet. Logicism forbids any intuition of number to sneak in either as an axiom or by accident. The goal is to derive all of mathematics, starting with the counting numbers and then the irrational numbers, from their laws of thought alone, without any tacit assumptions of before and after, or less and more, or to the point, successor and predecessor. Gödel 1944 summarized Russell's logicistic constructions, when compared to constructions in the foundational systems of intuitionism and formalism as follows. Both of these schools base their constructions on a mathematical intuition whose avoidance is exactly one of the principal aims of Russell's constructivism. History. Gödel 1944 summarized the historical background from Leibniz's In Characteristica Universalis, through Frege and Peano to Russell. Frege was chiefly interested in the analysis of thought and used his calculus in the first place for deriving arithmetic from pure logic, whereas Peano was more interested in its applications within mathematics. But it was only Russell's Principia Mathematica that full use was made of the new method for actually deriving large parts of mathematics from a very few logical concepts and axioms. In addition, the young science was enriched by a new instrument, the abstract theory of relations. Klein 1952 states it this way: Leibniz first conceived of logic as a science containing the ideas and principles underlying all other sciences. Dedekind and Frege were engaged in defining mathematical notions in terms of logical ones, and Peano in expressing mathematical theorems in a logical symbolism. In the previous paragraph he includes Russell and Whitehead as exemplars of the logicistic school, the other two foundational schools being the intuitionistic and the formalistic or axiomatic school. Dedekind 1887 describes his intent in the 1887 preface to the first edition of his The Nature and Meaning of Numbers. He believed that in the foundations of the simplest science, viz., that part of logic which deals with the theory of numbers, had not been properly argued. Nothing capable of proof ought to be accepted without proof. In speaking of arithmetic as a part of logic, I mean to imply that I consider the number concept entirely independent of the notions of intuitions of space and time, that I consider it an immediate result from the laws of thought. Numbers are free creations of the human mind, and only through the purely logical process of building up the science of numbers. Peano 1889 states his intent in his preface to his 1889 Principles of Arithmetic. Questions that pertain to the foundations of mathematics, although treated by many in recent times, still lack a satisfactory solution. The difficulty has its main source in the ambiguity of language. That is why it is of the utmost importance to examine attentively the very words we use. My goal has been to undertake this examination. Frege 1879 describes his intent in the preface to his 1879 Begriffsschrift. He started with a consideration of arithmetic. Did it derive from logic, or from facts of experience? I first had to ascertain how far one could proceed in arithmetic by means of inferences alone, with the sole support of those laws of thought that transcend all particulars. My initial step was to attempt to reduce the concept of ordering in a sequence to that of logical consequence, so as to proceed from there to the concept of number. To prevent anything intuitive from penetrating here unnoticed, I had to bend every effort to keep the chain of inferences free of gaps. I found the inadequacy of language to be an obstacle. No matter how unwieldy the expressions I was ready to accept, I was less and less able, as the relations became more and more complex, to attain the precision that my purpose required. This deficiency led me to the idea of the present ideography. Its first purpose, therefore, is to provide us with the most reliable test of the validity of a chain of inferences and to point out every presupposition that tries to sneak in, unnoticed. Russell 1903 describes his intent in the preface to his 1903 Principles of Mathematics. The present work has two main objects. One of these, the proof that all pure mathematics deals exclusively with concepts definable in terms of a very small number of fundamental logical concepts, and that all its propositions are deducible from a very small number of fundamental logical principles. A few words as to the origin of the present work may serve to show the importance of the questions discussed. About 6 years ago, I began an investigation into the philosophy of dynamics. From two questions, acceleration and absolute motion in a relational theory of space, I was led to a re-examination of the principles of geometry, thence to the philosophy of continuity and infinity, and then, with a view to discovering the meaning of the word any, to symbolic logic. Epistemology behind logicism. TBD. Dedekind and Frege's epistemology needs expansion. Dedekind and Frege. The epistemology of Dedekind and Frege is not as well defined as that of the philosopher Russell, but both seem accepting as a priori the customary laws of thought concerning simple propositional statements. These laws would be sufficient in themselves if augmented with theory of classes and relations between individuals X and Y linked by the generalization R. Dedekind's free formations of the human mind rebels against the strictures of Kronecker. Dedekind's argument begins with 1. In what follows I understand by thing every object of our thought. We humans use symbols to discuss these things of our minds. A thing is completely determined by all that can be affirmed or thought concerning it. In a subsequent paragraph, Dedekind discusses what a system S is. It is an aggregate, a manifold, a totality of associated elements A, B, C. He asserts that such a system S, as an object of our thought, is likewise a thing. It is completely determined when with respect to everything it is determined whether it is an element of S or not. Asterisk. The asterisk indicates a footnote where he states that Kronecker not long ago has endeavored to impose certain limitations upon the free formation of concepts in mathematics which I do not believe to be justified. Indeed, he awaits Kronecker's publishing his reasons for the necessity or merely the expediency of these limitations. Leopold Kronecker, famous for his assertion that God made the integers, all else is the work of man, had his foes, among them Hilbert. Hilbert called Kronecker a dogmatist, to the extent that he accepts the integer with its essential properties as a dogma and does not look back, and equated his extreme constructivist stance with that of Brouwer's intuitionism, accusing both of subjectivism. It is part of the task of science to liberate us from arbitrariness, sentiment and habit, and to protect us from the subjectivism that already made itself felt in Kronecker's views and, it seems to me, finds its culmination in intuitionism. Hilbert then states that mathematics is a presuppositional science. To found it I do not need God, as does Kronecker. TBD. There is more discussion to be found in Grattan Guinness re Kronecker, Cantor, the Krell Journal edited by Kronecker A. L. Philosophies of Cantor and Kronecker, Russell the Realist. Russell's realism served him as an antidote to British idealism, with portions borrowed from European rationalism and British empiricism. To begin with, Russell was a realist about two key issues: universals and material objects. For Russell, tables are real things that exist independent of Russell the observer. Rationalism would contribute the notion of a priori knowledge, while empiricism would contribute the role of experiential knowledge. Russell would credit Kant with the idea of a priori knowledge, but he offers an objection to Kant he deems fatal. The facts of the world must always conform to logic and arithmetic. To say that logic and arithmetic are contributed bias does not account for this. Russell concludes that the a priori knowledge that we possess is about things, and not merely about thoughts. And in this Russell's epistemology seems different from that of Dedekind's belief that numbers are free creations of the human mind, but his epistemology about the innate is intricate. He would strongly, unambiguously express support for the Platonic universals, and he would conclude that truth and falsity are out there. Minds create beliefs, and what makes a belief true is a fact, and this fact does not involve the mind of the person who has the belief. Where did Russell derive these epistemic notions? He tells us in the preface to his 1903 Principles of Mathematics. Note that he asserts that the belief, Emily is a rabbit, is non-existent, and the truth of this non-existent proposition is independent of any knowing mind. If Emily really is a rabbit, the fact of this truth exists whether or not Russell or any other mind is alive or dead, and the relation of Emily to rabbithood is ultimate. On fundamental questions of philosophy, my position, in all its chief features, is derived from Mr. G. E. Moore. I have accepted from him the non-existential nature of propositions and their independence of any knowing mind, also the pluralism which regards the world, both that of existence and that of entities, as composed of an infinite number of mutually independent entities, with relations which are ultimate, and not reducible to adjectives of their terms or of the whole which these compose. The doctrines just mentioned are, in my opinion, quite indispensable to any even tolerably satisfactory philosophy of mathematics, as I hope the following pages will show. Formally, my premises are simply assumed, but the fact that they allow mathematics to be true, which most current philosophies do not, is surely a powerful argument in the favor Russell and the paradox. In 1902 Russell discovered a vicious circle in Frege's Begriffsschrift, and he was determined not to repeat it in his 1903 Principles of Mathematics. In two appendices that he tacked on at the last minute, he devotes 28 pages to a detailed analysis of, first, Frege's theory contrasted against his own, and secondly, a fix for the paradox. Unfortunately, he was not optimistic about the outcome. In the case of classes, I must confess, I have failed to perceive any concept fulfilling the conditions requisite for the notion of class, and the contradiction discussed in Chapter X proves that something is amiss, but what this is I have hitherto failed to discover. Fictionalism, and Russell's no-class theory. Gödel in his 1944 would disagree with the young Russell of 1903, but would probably agree with Russell's statement quoted above. Russell's theory had failed to arrive at a satisfactory foundation of mathematics. The result was essentially negative, i.e., the classes and concepts introduced this way do not have all the properties required for the use of mathematics. How did Russell arrive in this situation? Gödel observes that Russell is a surprising realist with a twist. He cites Russell's 1919 to 169. Logic is concerned with the real world just as truly as zoology. But he observes that, when he started on a concrete problem, the objects to be analyzed soon for the most part turned into logical fictions, meaning only that we have no direct perception of them, in an observation pertinent to Russell's brand of logicism. Perry remarks that Russell went through three phases of realism: extreme, moderate and constructive. In 1903 he was in his extreme phase. By 1905 he would be in his moderate phase. In a few years he would dispense with physical or material objects as basic bits of the furniture of the world. He would attempt to construct them out of sense data, in his next book Our Knowledge of the External World, 1914. These constructions in what Gödel 1944 would call nominalistic constructivism, which might better be called fictionalism, derived from Russell's more radical idea, the no-class theory, according to which classes or concepts never exist as real objects, and sentences containing these terms are meaningful only as they can be interpreted as a manner of speaking about other things. See more in the criticism sections below.